Now let me introduce you what exactly we mean by determinant. To every square matrix, say A equal to Aij n by n, that is of order n, we can associate a number, real or complex, called the determinant of the squared matrix A, and is denoted by this symbol determinant A, like you use modulus A. Now, for example, if A is a matrix of first order, say A 1 by 1, then the value of determinant A will be A only. Now, example 2, suppose it is a second order. A is a matrix of second order, that is A11, A12, A21, A22. Then determinant A, first write it under determinant symbol, A11, A12, A21, A22. So what is the value of determinant? To evaluate it, first you multiply the elements of the main diagonal, that is A11 into A22, and minus the product of the elements in the other diagonal, that is A21 into A12. For example, if we are given a matrix A as 2 minus 1 and 3, 4, then how do you evaluate the corresponding determinant? We first write determinant A equal to determinant symbol 2 minus 1, 3, 4, multiply the elements on the first diagonal, on the main diagonal, 2, 4, 8, minus on the other diagonal, minus 3, so 8 minus minus plus 3, the value of determinant is 11. So that's how you evaluate the determinant of first order and second order. And now the third one, which is very important in the process, how to evaluate the value of a determinant of third order. Evaluate the determinant of third order. That is, directly now I'm writing determinant A as a determinant A of third order using the symbol for the elements as we have used in general for a matrix of third order, that is A11, A12, A13, A21, A22, A23, A31, A32, A33. Now how to evaluate? Now please note that we can expand determinant, this determinant A, we can expand with respect to or along any one row or column by multiplying each element of that particular row or column, delete the element through that, delete the row and column through that particular element, and multiply with the rest of the determinant of second order, and take a proper sign along with every element. What do you mean by proper sign? Let me tell you about proper sign. The sign are assigned, the convention is minus 1 to the power I plus j. Look here. For example, here you have 1, 1. So minus 1 to the power 1 plus 1, 2. Minus 1 to the power minus 1 to the power 1 plus 1, that is 2 to minus 1 square will be what? Plus 1. So we'll take plus. And then minus 1 to the power 1 plus 2 will make it 3. So it will be negative. So you find it will be negative. Then with 1, 3, it will be see 1 plus 3, 4. So minus 1 to the power 4 will make it positive. So you will find that the signs to be allotted before each element to evaluate the value of determinant will be plus, minus, plus, minus, plus, minus, plus, minus, plus. That the element on the main diagonal and the other diagonals will remain positive and the 4 in the middle will remain negative. Now let me expand it with respect to first row. Let us expand or evaluate the determinant A of third order along R1. So we will take the elements of R1, that is A11, multiply it, and of course the sign before A11 we will take positive, and delete the row and column through A11. Delete the row and column through A11. Then what is the rest of the determinant? The rest of the determinant left is A22, A23, A32 and A33. And of course, this you can evaluate as A11 as such. How do you evaluate the value of the second order determinant? You know the procedure. Multiply the elements on the main diagonal and minus the other diagonal, and the product of the elements on the other diagonal. So we take A11 times the determinant of second order obtained by deleting the row and column through A11, then minus times. You know that we have alternate plus minus, plus minus plus. So minus times the second element of the first row is A12. Again you delete the rows and column through A12. So what do you get by deleting the elements through A12? You get A21 delete the row and the rows and column through A12. So then you left with what? A21, A21, A23, then A31 and A33. And you can of course work out the value of this determinant, multiply the elements on the main diagonal minus the other. And plus, what will be the third term here? Okay, what is the third element in the first row? A13 times the same procedure, delete the row and column through A13 and you will left with A21 and A22, and elements in the second row will be A31 and A32. So in the second step you have A11 times the value of this determinant minus A12 times the value of this determinant and plus A13 times the value of third determinant of second order. So how do you evaluate the value of determinant of third order? We expand it first of all with respect to any one row or column by multiplying each element of when we are expanding it with R1. So multiply each element of R1 with a proper sign, delete the row and column through it, and then multiply with the determinant of second order obtained by deleting the row and column through it. So let me take an example of third order. Take an example. Say here directly I am writing determinant of third order. For example, you have 3 minus 2, 3, 4, 2, 1, minus 1, 4, minus 3, 2. You know the sign convention, plus, minus, plus, minus, plus, minus, plus, minus, plus. So let me expand it with R1. So you take the first element of R1, that is 3, or positive 3 of course, with plus sign, eliminate the row and column, delete the row and column through this A11 or 3, so you left with 1, minus 3, 2. And minus times the second element. What is the second element of first row? It is already minus, so we will take minus times minus 2. Now delete the row and column through minus 2. Row and column through minus 2. So what is the rest of the determinant? Rest of the determinant is 2, minus 1, 4, 2. And then the third element with plus sign, that is plus 3 times, delete the row and column now through 3. So then you are left with 2, 1, 3 times 2, 1, 4, minus 3. And now it is simple to evaluate it. That is 3 times, take the product on the main diagonal, that will be 2, and minus on the other diagonal, it will be minus 3 into minus 1, so plus 3, so 2 minus 3. And minus minus plus 2 you get here, so you will get it, take the product on the main diagonal 4 and minus minus plus 4. And similarly the third term, 3 times 2 into minus 3 is minus 6, then minus times the product on the other diagonal minus 4. And now just work out, it is 3 into minus 1 plus 2 into 8 and plus 3 into minus 10. So you get minus 3 plus 16 and minus 30. So the value is 16 minus 33, that is minus 16. So finally I conclude that the value of determinant is minus 13. I told you when I was just discussing with you how to evaluate the value of determinant of third order, that we can evaluate it along any one row or any one column. Normally we do with respect to first row or first column. Now just to illustrate you, let me see whether we get the same result if we expand it with respect to column 2. So alternatively, let me expand the same determinant with the elements of column 2. Now remember the sign convention, plus, minus, plus, minus, plus, minus, plus, minus, plus. So when you want to expand it with respect to the second column, which is this, so we'll take minus time, plus time and minus times. So it will be, the first will start with minus times minus 2 into, delete the row and column through minus 2, and you get 2 minus 1, 4, 2. Then the second element of the second column is 1, and we'll take it positive times, so it will be plus 1 time, delete the row and column through 1, you get 3, 3, 4, 2. And then take the third element with negative sign. The third element of second column is minus 3. Minus times minus 3, delete the row and column through minus 3, and you will get 3, 3, 2 minus 1. 3, 3, 2 minus 1. Now it is simple. So you get minus minus plus 2 times 4 plus 4. And here you get plus 1 time. So it's okay, plus 1. 6 minus 12. And minus minus plus 3 times minus 3 minus 6. So you get 4 and 4, 8 to the 16 and minus 6. And here you get minus 9 into 3 minus 27. So that is equal to minus 10 and minus 17. So again you get minus 17. So what do you observe here, that whether we expanded it with respect to the first row or second column, that means with respect to any one row or any one column, the value of the determinant should remain the same. Now please make a note here. There is no doubt that we can expand it with respect to any one row or column, but it is always preferable to expand with respect to that particular row or column which involves the maximum number of zeros. It will be very convenient. For example, suppose we are given a determinant, the elements of the first column are 1, 2, 4. Elements of the first row are 1, 2, 4. That of the second row are minus 1, 3, 0. And of the third row are 4, 1, 0. Can you tell me that we should expand it with respect to which particular row or column? You find that in the third column there are 2 zeros. So we should expand it. It will be convenient to expand with R3. Expand it with C3. This third column. How do you expand it? You already know the sign convention. Plus, minus, plus, minus, plus, minus, plus, minus, plus. So here it will be plus 4 times. 4 times the value of determinant A will be 4 times. Delete the row and column through 4. So you get the product on the main diagonal. I am doing it now directly. Minus 1 into 1, minus 1. And the product of the other diagonal will be 12. So minus 12. And what about the other terms? Obviously minus 0 and whatever the determinant is plus 0, whatever the determinant. So the other terms will automatically be 0. So we have saved a lot of time and energy, and you get 4 into minus 13, that is minus 52. So that is about how do you expand a determinant of third order in detail, and what do you mean by determinant, what is the value of determinant of first order, second order and third order.